Good afternoon, everyone. My name is Srini Viswanatha. I'm from Meta. I'm here to talk about Presto, or what I would like to call PrestoPy actually, but whatever. So it is in a name, right? So, but yeah, so I want to talk about the thing that I've been playing with this half, trying to get Presto users to be able to use Python from within SQL. So you all heard about a PySpark, right? So this is nothing like that. That's all. I just wanted to make sure upfront that this is nothing like PySpark. This is a completely different way of doing things because Presto is SQL. So we do SQL for everything. So and if some of the long-time users might know, we had something called remote UDF. How many of you heard about this? We used to have remote UDF way back, I think 3 years ago probably. But then the project was kind of stopped after that. We're kind of reviving that, except this time with a more targeted way of just supporting Python. Previously, we were supporting Java because Presto was all Java, but now Presto is going native first, almost like going to be right. So we decided to go with Python because also looks like a lot of the Gen AI and feature engineering, all these workloads love Python because there's a lot of libraries out there that are useful for this stuff. So we decided to actually add Python UDF support in Presto. That's what it is basically. So it doesn't even need a name because just a feature. We're just extending Presto to with a remote Python UDF. Okay, so what is the motivation? Why do you want to do it? So I had a lot of explanation to do to my bosses because why are we doing it? We have PySpark, right? So but the thing that I want to bring is like a lot of times people want to use Python for things that SQL is either hard to do or it's not even available. Like say, I don't know, third-party libraries, I don't know, some CV library or something, computer library, if you want to use, you cannot, right? So in Presto, Spark makes it easy to use, but not Presto. So that's why one of the main motivations is like enable people to use their Python stuff at scale, right? Presto gives you scale, so it will be nice if you can actually use Python with that. That way you can actually scale your processing. So that's the first one. And the second one is like marketing, right? Everybody has to do Gen AI so it's like Gen AI, yeah. So we are going to support Gen AI use cases because they're all Python stuff. That's that. The next one is like again kind of repeating the myself, but it's like there are a lot of popular libraries. We want to make them a little bit more seamlessly accessible from Presto. The last one is very interesting because we were showing it to a bunch of internal DEs, and then one of them came up with this last one, which is like, oh man, that is so good. I can actually get rid of this stupid transforms and lambdas, and I can write Python instead. That's actually very interesting because I did not think of that use case. I just hung up on Gen AI. I did not even consider that use case. So that's what I mean. So that's why, in some sense, I feel this is more like enabling technology. Like it actually enables it opens up a lot of possibilities for people to do cool stuff with. Combined with SQL, right? Because I think Presto Power is in SQL. We have a lot of optimizations and everything. So this actually gives you best of both worlds. So that's why motivation for doing this stuff. So what is it? So it's very simple. So it's so right now we call it FB invoke Python script, whatever. So we have some name, so we can figure out. So right now, okay, one thing that I want to make sure upfront is right now it's all internal. We are doing closed source for now at Meta. We want to first make sure that kind of works before we actually put it on the open source. But so anyway, so that's why you see the FB underscore. That's our internal function right now, and we actually made it a very general thing in that you can actually pass a full Python script as a string to this script to this UDF. So this UDF takes a Python script and a bunch of arguments, and then it's up to your Python script to process those arguments. That's it. We just give you all this thing, and then you do your thing on your side. So that's the design principle here, and the thing is we want everything to be JSON. All the arguments are passed in as JSON as a first cut, because one of the problems otherwise you have type mismatch issues, right, everywhere. So hey, what is int, what is long, what are those kinds of problems? So we don't want to have all those issues. So we pass all the arguments as JSON objects to Python. Will it scale? So we need to see. I mean, maybe we can add some primitive types at some point, but for now we're just saying everything is JSON. So we have to use JSON. So that's what we do. Because the hope is that that you don't pass too many things to Python. Basically, you just give it some file name or some URL, something. You go do your own thing from within your Python library. You won't be passing too much data to the Python script. That is the assumption that we are making, but it could be wrong. But that's what we are thinking for now. Like we'll just call and you can do whatever you want on your side. So if it's image processing, we'll just give you the image address and you can process it in your Python script. So that's why it's like, that's why we designed it very simply, right? In a very clean and simple fashion. And the only thing is, the interesting thing is, like, you can unlike most Presto UDFs, here you can actually pass a script, full-blown script. You can actually, as you can see, one example here, right? So yeah. So the second part is very important. Use SQL for SQL things. So if you look at this is one of my pet peeves about PySpark, because people do things like aggregations, joins from within Python. Sometimes they actually are suboptimal. So wow, I'm actually doggedly pursuing this, which is basically saying you use SQL for SQL things. You don't do it in Python. So if you have a join, if you have an aggregation, do it in SQL. Let Presto do its thing efficiently in SQL. Then you call your Python for the aggregated values if you really want to do. So that's the example that we are showing here. So this is first part is fine. I'm just producing a random value table with x and whatever, two values. So here you can see I have a Python. Okay, so this inline thing is some internal detail. We're going to, so once we make it open source, we'll clean up all these things. But for now, it's called inline, whatever. So as you can see, it's actually a full Python script, with full indentation, everything, right? You have to indent your Python properly here. So it is a full Python script. And then it actually sends a bunch of things. As you can see, sys.argv, that's how you pass all the arguments, right? You get them as sys.argv. And then you can actually do whatever. So in this case, this example actually showcases a very interesting use case, one of that we were talking about, which is NumPy. So if you look at Python, Presto doesn't have a median aggregation. So, but I know NumPy has it. Can I use it? Now you can with this. So that's what we want to say. Hey, you found something that you want to use. Now you go ahead and do it. So that's the idea. So that's what we are trying to do. In this case, it is a simple. What I do is I do the array of the value, and then I call, numpy.median on this. So it's up to you if you want to put it in some file and call it median.py and then include that here. That's one way to do it. So authoring part we haven't figured out. Here it is, everything is written inline. So we need to figure out authoring part. But this is the general idea. So just call. If you look at here, right? So yeah. So the first part is the script, and the second part is JSON format. So you need to send us a JSON values, and the more important, interesting thing is this part. You do the array ag and group by shuffle index. So basically, you do your aggregation in SQL here, and then send the values to Python to do further processing. Right? So this is a little bit internal. We have this thing called a sidecar process. We are trying to get away from it at some point and make it like maybe Velox UDF, right? Feilong, we can make it as a kind of a Velox internally. We can just call. So the main idea is like there is a Python server. So this is all remote. It's not in process right now. It's all remote. So the idea is we'll pass the server address, and the UDF can actually call that, right? That's configurable. That's what we want to do. And the UDF can potentially be just in Velox eventually, right? Directly we should be able to call it from Velox. Yeah. So that's the whole idea. Right now we're just putting it in our side process. We have something called a sidecar. It's our internal tool where we can actually run things side by side with Presto. And then we actually ask that guy to do on our behalf, call the remote UDF. But there is nothing preventing us from moving it into Velox as a way to call it. So Python service actually is so it actually does a Python script to AST and evaluates against the provided input. So basically we do have some caching now, right? So we cache, yeah. So basically it does it parses the Python script and then does eval on it. And then we do some code caching, so it doesn't compile every time, which will be super slow. So, yep. Question? Yeah, exactly. Yeah. So if you have multiples, you should be able to distinguish. Yeah. So that's the idea. Yeah. No. So like I said, we are still in this is almost like a prototype. That's why it's a lightning talk. So it's like, we are still trying to figure out because there is still the issue with when we have PySpark, why do we need this? That's another question that we need to answer. Yeah. Yep.
And I had another question, which was, is this implemented as a function namespace manager?
Yes. Yeah. So it's all properly implemented. So the front end side, the language side is all clean. Just the implementation is sitting in sidecar right now, but we can move it out. That's what I'm saying. So we try to build it as cleanly as possible to eventually open sourcing it. Yeah.
Gotcha.
Yeah.
So in theory, like you could do create function. Here's my Python code, parse and compile the Python code, and then throw
Oh, okay. That's next level. So we have not thought about that, but yeah, that could be an interesting one. Yes. Yep. Yeah.
On the previous slides,
Yeah.
so RP1, what is this bound to?
Sorry, which one?
The JSON loads?
argv1.
Yeah.
So that's a Python syntax. In Python, it's sysargv. It's basically like argv for any.
What are you passing in?
So here, sorry, that is the second argument here, right? So up to this quote is the first argument. So if I click, it's going to go away probably, but sorry. So if you look at, right, so this is the, so the Python code starts here and goes up to here. This is the Python code, and this is the second argument. So we should put some comments there so we can fix the slide. So this is the second argument, which is the JSON, yeah. So you can pass any number of arguments, but right now we just have a single example, yeah. So one of the first questions everybody asks is, what about security? What if my Python code does random stuff? It's like, well, okay. So so one of the things is Presto actually has this notion of a identity, right? Security identity that we have for the execution, the identity of the executor of the query, I guess. I think something we have at ACLs and things like that. So we are hoping that some of those things, and also your deployment will hopefully have enough, lockdown that it won't call anybody. So, but eventually maybe we want to run it in a sandbox. That will be an interesting thing at some point. Yeah, we haven't given too much consideration to security because within our internal deployments, we know that our remote Python server that we are using is deployed on a secure system. So we know it can do random stuff. So it can destroy other users, that's okay, that's fine. But it can't even destroy other users. It is because it's in a sandbox on its own. So one of the ways of deployment we are considering is bring your own server. So basically, we don't want to own the server. You bring your own server. That way you can put all the packages that you want on that, knock yourself out. Because right now, that's another issue, right? If you see, I also have import sys. It's like you don't have nothing, so we have to import everything. So, but if you bring your own server, you should be able to configure it too, so that all things are actually already available and things like that. So these are some deployment considerations. We haven't fully considered all the deployment scenarios, but those are things that we are looking at some point. Yeah, so performance. So I think we looked at some of, I think it is not, it's like 10x or 100x if you come, yeah. Yeah. No, just latency. Let's talk about just latency. 10x, yeah. So I think so if you do the same thing, if you can, so we basically wrote some example where you can do the same thing in SQL as opposed to in Python, and that is about 10x. Like the lambda thing that we were talking about, that we actually wrote lambdas in Python, if you move it to Python as a for loop instead of a lambda in SQL, it's about 10x slower for now. But we haven't fully optimized it. Originally, when we started, it was like 1000x slower. It was like crawling. But we already did this, code cache that Pradeep worked on some of these things. So it was, it helps. So right now we're at 10x range. But we can do more, I guess. We can do a lot more. Yeah, especially if we implement primitive types, we could get some more improvement. Because right now everything is JSON. JSON parsing is very expensive. So we can do some things there, yeah. And then here we have a demo that Pradeep put together, this thing in action actually, wanted to show you guys. It's the same example that we had in the first slide. Let's see, will it play the sound also?
Meta. This game-changing functionality allows us to seamlessly execute Python scripts within our SQL queries, unlocking unprecedented flexibility and power for data processing and analysis. So what kind of challenges can we solve with this functionality? Well, here are a few examples. We can use Python to perform complex data transformations that aren't easily achievable with SQL alone. We can create custom aggregation functions using Python, allowing us to perform calculations that aren't natively supported by SQL. We can also perform inference and predictions directly within our SQL queries utilizing pre-trained models. These are just a few examples, but the possibilities are endless. For our demo today, we'll demonstrate how to leverage the UDF functionality to compute the median, a function not natively supported in Presto. We'll work with a dataset containing random values. So specifically, we'll create this table with two columns, shuffled index and random value. The shuffled index column will contain shuffled indices from 1 to 128, while the random value column will contain values between 1 and 1000. Now, let's take a look at the Python UDF that we'll be executing. This function takes an array of random values as input and returns the median value using NumPy's median function. This function is simple yet powerful, and it demonstrates how we can leverage Python's capabilities to perform complex calculations within our SQL queries. Now let's execute the query and see the results.
Proof that it works.
As you can see, the Python script runs returning the median value of each shuffled index. This integration not only enhances our analytical capabilities, but also simplifies complex data processing tasks. In conclusion, the ability to execute Python scripts within Presto opens a world of possibilities. It bridges the gap between SQL and Python, allowing us to leverage the best of both worlds. Thank you for your attention, and I hope you are excited about this feature as I am.
Yes. All right. There, that is Pradeep's talk. Yes.
So it is a scalar UDF from a SQL.
Yes. Yeah. So right now it is just a scalar function.
In terms of value binding, you can only pass in JSON.
JSON. Yes. JSON and JSON out. That's our current design.
Not thinking of passing any SQL binding.
Yeah. I mean, so the problem is always we get stuck with this whole type translations and then serialization, deserialization is a big problem. That's why I think JSON or maybe Thrift at some point might be another option that we looked at Thrift also, right, Pradeep? Thrift is a possibility. Oh, arrow. Okay, so arrow format. Yeah. So I think so there are possibilities, like I said, but we are just sticking. Right now we are keeping it very very simple with JSON. Yeah.
Because otherwise, with JSON, you have to always do the parsing on JSON and just adding.
Yeah, yes, that is true. I think there are some, but yeah, I think we said like most of the time is spent in JSON parsing. That's what you said, right? Yeah, okay, yeah.
And it's a scalar UDF, so if I invoke it, 100 million times, that adds up very quickly.
Yeah, like I said, it's about 10x slower is what we observed, yeah.
And you're thinking about providing a table function for it?
Table valued function? I mean, Presto doesn't even have TVFs anyways. It doesn't have table value function. But you can return an array and then unnest it. That's a TVF equivalent, more or less. You can get small tables. You just send an array and then return an array and then you can unnest it. You can unnest the result of a Python output. That will be kind of a TVF for you. Yeah.
Almost.
Yeah. So I mean, we don't have TVF notion at all in Presto. So yeah. So that's but unnest is the closest thing that you could. Yeah. Yeah. Yes. Yep. Yeah.
Because, so I think like part of what makes the function namespace managers difficult to build are that you have to build two different things. You have to build the implementation of the function namespace manager itself, and then you also have to design an API. So, like almost certainly that would be something that you have to do from scratch. So that was part of the motivation for using a REST-based API. So basically you just use one namespace manager
Yeah.
for the function namespace manager, and you just implement a service that implements the REST-based API. So it's not necessarily a question, but food for thought.
Observation. Yeah.
That helps with that, then perhaps we could use that REST-based API.
Yeah, yeah, that makes sense. Yeah. So like I said, this is still the very beginning. Like we just got this demo done maybe a couple of months ago, so we are still shopping it around to see. But yeah, so I see a lot of interest in this, so that will be good for us to get more support from the community to make this happen. So that's one of the good motivations here to see like how the community could like this stuff. Yeah.
Even things in our Python system, like the ability to register Java and other functions, like in a generic way.
Bring back your remote UDF. You're saying.
Right, but what I'm like there's infrastructure costs associated with that, but it seems like you're ameliorating those infrastructure costs by just making it co-located with the worker, which I think is pretty smart. And so some of the frustration with the earlier effort
Oh yeah.
concentrated around the deployment model of it rather than inherent to the implementation itself.
So I want to actually clarify something. I don't think we are co-locating the actual Python code. Python is still in the server. Just the remote, the UDF is sitting in the sidecar. It's co-located. Remote server is still the server. Python part is still running externally. So we might bring it internally, but I don't know if we will ever do it. So right now, because just for security point of view, it's better to just sit outside somewhere. So that's why I'm saying like we're actually trying to even think of saying like, hey, bring your own server. That's actually even better. So we'll try to take care of all the parsing, analysis part, and then we can improve all those things. But at the end of the day, it's your responsibility to bring your server and then make it secure and all that stuff. So yeah, so I mean, yes, there are some security is a big thing that we still need to work out all the details. There are a lot of questions that are coming even within Meta. So yeah, but we just wanted to show, like, if there is a lot of interest in this stuff, we can potentially continue the development and then open source it at some point. Yeah. Yep. Yep.
This is a stupid question, I apologize. But what's the difference between doing it this way and then doing it within what I'm used to as a stored procedure in whatever language, which would be a local UDF? Is that what that would be? Is it just the difficulty of having all the Python libraries in it supported and all that? That's the challenge, and then keeping it up to date?
Yeah. So I think it's a multi-tenant shared service, right? So that's a big problem. So if you just allow some random Python to run, they could actually bring down the service for the other users and things like that. So that's our issue. So that's one of the main considerations. So that's why it's best. That's one of the things that I could think of. The other one is, like, we don't process any of them. We don't even have the notion of a stored procedure, right? So Presto is not like fully fledged system like Oracle and all the DB2 and all these legacy systems.
You can partition those calls out
Yeah.
so that it can't damage the kernel or the rest of or anything.
Yeah, sandboxing. Yeah. So yes, we don't have any of those. Yeah.
Yeah, it passes it to that if it closes
So okay. So actually, if you look at our this sidecar process is somewhat like that. So the sidecar process is actually running on the same machine, but not in process. It's outside process, right? The sidecar process is outside, right? Yeah, it's a separate process. It's that can actually for these purposes only. So we can actually make calls out to other people without disturbing the other users. Yeah. But yeah, we don't have stored procedure. I mean, if you look at this almost looks like stored procedure. Yeah, exactly, right? The whole Python script is inside there. So yeah.
Because if you made a stored procedure, you can just invoke it.
Yeah. So that we consider as an authoring issue here right now. Yeah. So that's what we are actually kind of saying. Hey, authoring is something that you have to figure out. We haven't figured out the authoring part of it. Yeah. We just want to build the basic core technology, and then now we need to figure out how to do the authoring. Because that was a problem even with the remote UDFs. I don't know if Tim, you remember.
You can reuse it, etc.
Yeah, exactly. Yeah. So I think so I can give one more answer to that, which is basically we had this notion of whatever config file. What is that thing? The configurator, right? So we can actually we have ways of keeping scripts in a secure location, so to speak, within Meta. So one of the that's why it's called internal. But we have another version that actually takes a path and runs a script from that path. It's like stored procedure, but it's stored file basically. So yeah, we are trying to. But this one is kind of more vanilla demo without any of those funny stuff that we have. So we can potentially make it like you can include a script, and then we can potentially say, hey, look up this path. This is the location to. This is the base directory, or I don't know, maybe GitHub URL or something where you extract your Python from or something, right? You can go crazy, so you can just invoke random stuff. So it's all like how far do you want to go? That's what we're trying to figure out. So, but we are trying to allow them to maybe edit Python inline. We have some UIs within Meta that we use. So that's query. We wanted to use some of those kinds of things. Yeah, yeah.
Just to better understand the inlining aspect, so can the first parameter actually be a column?
Yeah.
It can be a column.
Yes.
So that it's not exactly inlining though.
Well, yes, yeah, yeah. You can be any. You can put any column. Yeah, sure, yeah, yeah.
One other, I just wanted to see if you considered this. So, like, it seems like one of the motivations is to open up the Python authoring experience to users. And there are open source projects that basically kind of bridge the gap between Python data frames and SQL systems.
Okay.
And I was curious if that also would satisfy some of the requirements that motivate this group. So, for example, like there's a project called actually IBIS, which will
Yeah.
take Python data frames and translate that to SQL queries. And that.
So I mean, I personally, I'm not a fan of IBIS. There was an effort a couple of years ago. We started doing that IBIS thing. I was not sure if it's the right way to go, because I think you're right. Presto is SQL, right? It's synonymous with SQL now. So basically, so at least within Meta, that's what it is. For SQL, you use Presto. That's what we kind of promote. So, and then Presto is a kind of standard, one of the most standard compliant engine. So I think it's best to stick to SQL and then maybe treat Python as external. I think the DNA of Presto is different from the rest of the other systems, which actually help you let you build plans And I'm not a fan of that. Like, if you look at PySpark, I've seen people building random plants that do shuffles all over the place. It's like, why are you doing all this stuff, right? Just write SQL, then it'll be a lot easier to triage. See, because one of the problems is with the maintenance, right? When people start building plans, they'll build almost always suboptimal plans. And then you don't even know how that plan came about. If you're a support person, it's like, how did this come about? So, right, you have to go and trace some Python code. Whereas SQL is a little bit more declarative. You can say, oh, you're putting this order by here, that's why it is so slow, or something like that. So we don't have that kind of visibility. So that's why I'm a little bit, against IBs. But I know there's a lot of interest in that. A lot of people want to do those kinds of things. So I'm not saying like, we don't want to support it, but maybe in the future we will do it, because that might also be a way for us to kind of seamlessly move between PySpark and Presto, and right. So yes, there are benefits to that. There is no question about it. But we want to actually go with SQL first nature of Presto, and then support it from that point of view, and then see if there are other places where we want to go for to improve the adoption. Yeah. Yep. Yeah. Anything else? All right. Thank you very much. And then I'll thank Pradeep and Feilong, who worked on all the front end and back end stuff. So I'm just here talking. So thank you.